Hello and welcome to this R tutorial. We are finally getting to the final round of our classification adventure in our machine learning journey, because today we're making the very last classifier, the random forest classifier. So this classifier is basically the daddy of the previous classifier, the decision tree classifier, because very simply, a random forest classifier is a team of decision trees. So you will see that we will pick a number of trees to compose our random forest, and then when it is time to make a prediction, then each of the trees of the random forest will each one make a prediction, whether or not they think that the user would buy yes or no the SUV. And then the random forest will look at each of the votes of its trees, and then will count the number of votes for each class, that is the number of votes for yes, the user bought the SUV, and the number of votes for no, the user didn't buy the SUV. And simply based on a majority vote, the random forest classifier will choose the class that received the majority vote, that is the most votes from its trees, to make it as its ultimate prediction. So that's the idea about random forest, and therefore if you understood correctly decision trees, then you would have no problem to understand random forests. Okay, so let's make our very last classifier right now, and let's find out about the results. So let's start with the basics. We'll go to our machine learning AZ folder to set the right folder as working directory. So this right folder is in part 3 classification, and here it is, section 20, random forest classification. That's the right folder. And as I was telling you, we are reaching the end of part 3 classification, because the next section will be dedicated to evaluating classification models' performance in order to improve the models, and therefore this is our last classifier. So let's go to this folder. That's the folder we want to set as working directory. Make sure that you have the social network add CSV file, and if that's the case, click on this more button here and then set as working directory. All good here, and now let's go to our classification template to build our random forest classifier with the best efficiency. So we'll just take everything from here to the bottom, copy, and then we'll paste it here. Alright, so I'll just give a quick reminder about what this template is doing. So the first step is to import a data set. We are importing the social network add CSV file that contains some data about users of a social network and their information like their age and their estimated salary. So this car company has just launched its brand new SUV at a ridiculous price. Put ads on the social network, and the last column of this social network add CSV file tells if yes or no some users of the social network bought the SUV. So 0 if no and 1 if yes. Then we encode here the target feature as factor, because we sometimes need to do it for the classifiers that we build. We're just doing this to specify to the classifier that our last column purchased is a categorical variable with factor levels 0 and 1. So we don't need to do it for all the classifiers, but we do need to do it for some, like the naive-based classifier as we saw. So it's good to keep this code section in the template. Then we split the dataset into the training set and the test set. So as a reminder, the training set is where our machine learning model, that is our random forest classification model, will learn the correlations between the age and the estimated salary, and the question whether the user will buy yes or no the SUV. And then based on these informations, the machine learning model learns how to make some future predictions. And so we build this test set here to test the performance of our model in terms of predictions. And then in the last section of the pre-processing phase, we apply feature scaling to the data. And we are only doing this because at the end of this template, we make this very cool graph for both the training set result and the test set results that will plot the prediction regions and the prediction boundary. Okay, so right now we need to change a few things in this template, but some very few things. First, let's not forget to change the title of the plot. Here we'll replace classifier by random forest classification. We'll copy this because we'll do the same in the test set results. Here it is, perfect. Okay, and now what we only need to do is to create our classifier here, and then we'll be ready. So I'll just paste the same thing here, random forest classification to the training set, and now let's create our classifier. Alright, let's do this. So it's very simple. We're going to use a library that is called Random Forest. So let's do this. Let's first install the package with the command install.packages. So that's for those of you who are using this package for the first time, then you won't have it installed on your packages list here. As you can see, mine should be already here because I used it several times. Yes, there it is, Random Forest. So if it's not the case for you, then you need to install the package here. And so in this install.packages function, you just need to input the name of the library in quotes. So it's Random Forest. Be careful with the capital F here and not capital R here. All right, so that's what you need to input anyway. That will install the package. I won't do it because I already have mine installed, but what you just need to do is to select this and press Command and Control plus Enter to execute. And this will install the package without any issues. All right, so here I'll just press Command plus Shift plus C to make it as a comment. But then what I need to do is to add the command here, library, and then input the name of the Random Forest library. Because as you can see here, it's not selected. So I need to add this library Random Forest command to select it automatically, especially if I want to make some automated R scripts in the future. So that's the thing to do. That's very practical. And now we're all good. Let's create our classifier. Okay, so as usual, we'll start by creating the variable classifier. That will be our Random Forest classifier itself. And now we will use the Random Forest function to build our classifier. So here I'll just take the function Random Forest. And now let's see what arguments we need to input. So we'll just go here and press F1 to get some info about this function. So here we need to click here. And here are some info about the Random Forest library and function. So let's look at the arguments, which are what we're interested in. Okay, so the first argument is data. We won't need it. As you can see, it's an optional data frame. So it's not an argument that we need to build our Random Forest classifier. Same for subset and na.action. We actually don't need the three first parameters to build a Random Forest classifier. However, we of course need the x and y arguments here, which, as you can guess, will be the matrix of features and the dependent variable vector. Indeed, as you can see, x is a data frame or a matrix of predictors, so that's pretty clear. X is our matrix of features, our matrix of predictors, which are our independent variables, age and estimated salary. And then y is set to be a response vector. So of course, y is the dependent variable vector, that is the purchased column. Okay, perfect. And then the last argument that we will need to build our Random Forest classifier is of course the number of trees we want to have in the forest. And this number of trees is given by this entry argument here, which, as you can see, is the number of trees to grow. So to grow is a nice way of telling that the trees will learn from the data set how to make the predictions, and basically this argument is the number of trees. So remember in the Python tutorial we chose 10 trees? Well, let's do the same here. Let's pick entry equals 10. And that is actually everything we need to build our Random Forest classifier. Only x, the matrix of features, the matrix of independent variables, y, the response vector, the dependent variable vector, and entry, the number of trees. Okay, so let's do this. Let's input the arguments. Let's go back to R, and here we are. Okay, so let's input the arguments. As you remember, the first argument was the matrix of features, the matrix of independent variables, and that is training set, excluding the last column, which has index 3. Because as you remember, in the training set we have the first two columns, which are the independent variables, age and estimated salary, with therefore indexes 1 and 2. And we have the third column indexed by 3, which is our dependent variable vector purchased. So here -3. Then what was the next argument? The next argument was y, the dependent variable vector. And then here we'll take training set, and let's pick it this way to specify the name of the independent variable. So dollar here and purchased. Purchased is the name of our dependent variable column. All right, so we almost have everything we need. The last thing we need now is of course the number of trees, and that is entry equals 10. You can play around with the entry argument. You can choose many more trees in the forest. You'll observe some interesting results. That's interesting to see what different teams of trees can do to predict the response of your users in the social network, whether they buy yes or no the SUV. But if you do this, make sure to pay attention to overfitting, which you want to avoid. You don't want to overfit the random forest classifier to the training set, because if you do this, then it might make some poor predictions on a new set. You can actually check it out with the test set. But here we'll choose 10 trees and we'll see what happens. Alright, so actually we're done with the template. We changed everything we had to change, and now we can just, select everything and execute to make everything ready. You can actually take some coffee or tea and you can just select everything and execute to watch the results. But let's rather do it step by step. We'll just do the first pre-processing step all in once here. So I just selected the pre-processing phase, and now I'll press Command and Control plus Enter to execute. All right, all good. We have our data set, our training set, and our test set. So everything looks fine. We have 400 observations in total, 300 observations that went into the training set, and 100 observations that went into the test set. As you can see, the training set and the test set are scaled, because in the end we're plotting some graphic results with a resolution of 0.01. So in order for our code to execute faster and not actually break our code, we need to apply feature scaling to our training set and our test set. Otherwise, we wouldn't need to do that, because the random forest classification is not based on Euclidean distances, but it's based on, conditions on the independent variables. But because of this code here that is compute intensive, we need to apply feature scaling so that everything is well executed. All right, so let's do this. Let's watch the results. We just need to create our classifier here by executing this section. So here I'll just do this. All right. Okay, now let's predict the test set results. Then we have the confusion matrix, which will tell us in a flashlight how many incorrect predictions we have. So let's actually do it directly. It will be faster to see how our random forest classifier did well on the predictions. So let's execute this. And now let's enter CM here in the console, press enter, and here we have our confusion matrix. Okay, we have 7 plus 10 equals 17 incorrect predictions. Well, that's not too bad. Just for fun, let's just pick another number of trees. Like, for example, let's pick 500 trees. 500 trees is a lot. That's really a big army of trees to make some predictions. And now, just for fun, let's take this. I don't need to include this because my library was already selected from the previous execution of this code section here. So let's rebuild a new classifier with 500 trees, and now let's look at the confusion matrix. But before, let's build our vector of predictions, because right now the ypred vector of prediction is the one given by the random forest with 10 trees. So let's re-execute this. All right, now we have ypred as the vector of predictions predicted by the random forest with 500 trees. And now let's look at the matrix of predictions. Remember, with 10 trees we had 17 incorrect predictions. And now let's see, select, execute, CM, enter, and now we have 15 incorrect predictions. Great, we invested 490 more trees to win 2 correct predictions. So definitely that means that there are a lot of unuseful trees in the team. Okay, so as you want, let's maybe go back to 10 trees here, because obviously 500 trees is not very useful. All right, so I'll just take that again, that as well, and that as well. All right, and now let's look at the training set results. So everything is fine here. We changed the title here with random forest classification, so it's all good. We are ready to look at the graphic result. And by the way, you can pause on the video now and try to guess what you're about to see, try to guess the shape of the prediction regions and of the prediction boundary. If you understood correctly the decision trees, then you would have no problem guessing what's about to happen. Alright, so I'm going to execute right now, Command and Control plus Enter to execute, and showtime. Alright, wow, that's quite something here. Okay, so first I'll give a very short and quick reminder of what this is about. So the points here are the real observation points, that is the real users of the social network. The red points are the users who didn't buy the SUV, and the green points are the users who bought the SUV. And then we have the regions here, the red region and the green region, which are the prediction regions. So the red region is the region where our random forest classifier predicts that the user doesn't buy the SUV, and the green region where a random forest classifier predicts that the user buys the SUV. Okay, so in short, the points are the truth and the regions are the predictions. And now let's see, okay, so the random forest classifier definitely catches most of the users that didn't buy the SUV in the right category, that is the red region. So that means that it classified well most of the users who didn't buy the SUV. And same for the green users, who are the users that bought the SUV in reality, because as we can see, most of them are in the right green region. And it's desperately trying to catch some outliers. We can call them this way. For example, this guy here is a user that didn't buy the SUV in reality because this is a red point. And it is way into the green region here, as we can see, but the random forest classifier managed to make this little rectangle part of the region in red to catch this user that didn't buy the SUV and classify it well. But is it the smart way of doing this? Because what will tell you that for some new observations we will have, some users who didn't buy the SUV in this red rectangle here. So that looks like overfitting, because it made this red rectangle here because we had this user indeed who didn't buy the SUV, but nothing tells us that for some new observations we will have some users who didn't buy the SUV in this red rectangle here. So we should be careful with that. And same for this user here. As you can see, that this user is in some sort of a irregular red region here. But fortunately, our random forest classifier was not too obsessed at making all predictions correct, because as we can see, this red user here is in the green region. So that means that it still paid attention to overfitting, but not too much, and we should be careful with that. So speaking of overfitting, let's check that right now. Let's look at the test set results right now to see how these regions here, because the regions won't change. These are the regions built by our model. So when we look at the test set results, we will have the same red region here with this rectangle here and green region here. But what will change will be the test set observation points, that is all the red points and the green points. This will change, and we will see if we have some red points here in this rectangle here, and actually probably not, because this looks like overfitting that occurred because our classifier was fitted too much to the training set. So let's find out about that right now. Let's select this section dedicated to visualize the test set results. So I'll just select everything and press Command and Control plus Enter to execute. Alright, so what is the first thing you see here? Well, yes indeed, this red rectangle here is totally unuseful for some new observations. So that was clearly a red rectangle region to catch some users of the training set because our classifier was too much fitted to the training set. And this red rectangle actually doesn't make any sense here, because indeed we don't have any red user in this rectangle region here. Well, it's not that it doesn't make any sense, but it's totally unuseful here. And besides, we have this green point here, and this green point could have been in this region here that would make an incorrect prediction. We were lucky on this one, but this could have happened because these are new observations, and our random forest classification machine learning model didn't learn anything from this new observation point. So this guy could totally have ended up here. So lucky on this one. And by the way, same for this region here. We don't have any red user, that is some user who didn't buy the SUV in this red region. So this red region is totally unuseful as well. Okay, so that's the idea, but most of all, it did a pretty good job because of course it caught most of the red users here with a low age and a low estimated salary, and therefore users who didn't buy the SUV, and most of the green users who are quite older with a higher estimated salary who bought this awesome cheap luxury SUV. Okay, and now what is the conclusion of all this? Because we reached the end of our classification adventure. We built all our classifiers, so according to you, what is the best classifier for this particular business problem? What is the best one? It should be a classifier that classified correctly the users who didn't buy the SUV and the users who bought the SUV, and at the same time prevented overfitting in the training set to be able to make some good new predictions of some new observations. So, in my opinion, the best classifier would be the kernel SVM in terms of the balance between the percentage of incorrect predictions and the fact that we want to prevent overfitting. Well, if we look at them again, in my opinion, the kernel SVM classifier would be the best one. Alright, so that's the end of this tutorial, and now I have to say congratulations, because you built a great deal of classifiers from simple classifiers with logistic regression to more sophisticated and more complex classifiers like kernel SVM or random forest classifiers. But that's not the end of the journey. In the next section we will be talking about how to evaluate the performance of our models and how we can improve them. And then eventually we will have a homework on a real-life data set where we will combine what we learned here about how to build some classifiers and all the next concepts that we will learn to evaluate the model performance in order to find the best model for this real-life business problem data set that you will be given. And we will do the job as a data scientist or a machine learning scientist would do in reality. So congratulations again. I look forward to seeing you in the next section.